Greetings and welcome, geometricians. You might be confused because this looks like algebra. It is. This is the geometry book's lesson about algebraic reasoning, where you take something you know and apply it in a slightly different way so that the familiar allows you to feel comfortable with the unfamiliar concept of a proof. Wow, that was completely unrehearsed. I could be lying. Maybe I practiced that all yesterday during the snow day. But no, I didn't. It was completely unrehearsed. Here we go. It says, solve the equation. So let's see, mis amigos. There are multiple ways to solve an algebraic equation. As long as we all obey the laws of math, we will all eventually get there. Let's see what, Phoebe, what was your thought as far as, what would a good first move be? I'll do the work, you tell me what I should try. I don't know. Yeah, distributing. And a classic spot for error is to not include the minus sign in the second distribution. But not you guys. You guys would have caught that. So negative 2 times 3x is negative 6x. Negative 2 times 4 is negative 8 equals negative 18x. Let's see. Liam, what are your thoughts on a next good move? Okay, all right. Oh, can I combine these? Why? Because they're, man, check out Liam math. I'm telling you, he's got the good explanations there. Negative 6x and 36. All right, I was like, I didn't know if 32 was in there for some reason, but okay. And let's see, Emmett. With the alley-oop here, what do I do now? I like it. Oh yeah, we haven't even justified anything. Mm-hmm. It's called simplify. So the question was, is there a property for combining like terms? It's just like kind of order of operations, or simplify is what I've usually seen written. Yeah, you could just say combine like terms as well. I think that's an even more descriptive thing than just simplify. Now, I normally tell my Algebra 1 buddies to move the little guy to the big guy, but I think I agree with Emmett here, who's an expert when it comes to negative numbers, that you know, it's going to save us one step to move this over here rather than move the 18x and then have to move the 36. Like, we're saving one step. So we'd rather go deal with the negatives. So I'm going to have 36 equal signs. Notice, ooh, see how I line up my equal signs? Thing of beauty. So that's negative 12x. Let's see. Holden. What should I do now? Should I add 12 to both sides or something? I like it, yeah, because division is the inverse operation of multiplication. So it looks like negative 3 equals x, but that's how Yoda would say it. We would say it x equals negative 3. So in terms of justifications here, the first one was the distributive property of equality, right? Because they wanted us to justify each step. This we could call simplify, or combine comb-like terms. What did I do? Let's see. Oh, then I addition property. Right. Of equality. There we go. And then div prop. Yeah, fortunately, these are very aptly named properties. Like, it would have been really inconvenient if they named them different things. And then what was this last move here? What? Oh, that's the one. I always call it reflexive, but it is not. It is the symmetric property of equality. All right, not that bad, not that bad. So let's take a look at another problem here. Cruising right along. It says solve the equation, justify each step. So here's a formula if you will. You guys might know this formula, maybe not. They want us to solve for n. So the first thing I'm going to do, I could distribute, or I could divide both sides by 180. It doesn't matter. I'm gonna tell you what. I'm gonna switch it up. I'm gonna divide both sides by 180 here, just to show that it works. So I get capital S over 180 is equal to what is that equal to? Yeah, n minus 2. N minus 2. And then I would just add 2 to both sides. And so I'm going to write this as S over 180 minus 2. Ah, my equal signs aren't lined up. How gross. Oh, thank you. Yeah, with the save. That was Liam with the save. Liam math. Yep. And then I'll flip it around. I'll have n equals S over 180 plus 2. Yeah. Alternative, you could have, I believe, had something like n equals, what would have been S plus 360 all over 2, or all over 180. Sorry, you might have had that version as well if you did distribution first. And those are equivalent. What's your question? All right. My bad. So in terms of my reasons, I did div prop, right? Equality. Then I did add prop, equality, and then I did symmetric property of equality. Right? All right, cruising. Here we go. Oh, name that property. Everyone's favorite game show. Nice. If x equals y, then y equals x. Yeah, symmetric property of equality. Isn't Symmetra like an Overwatch character? I wonder if like there's any like meaning behind her name related to symmetry. I have no idea. I suppose most of the Overwatch characters being human, bilateral symmetry is a feature that many of them have. Even the monkey gorilla guy and the robot seem to be bilaterally symmetric. Let's see, how about this one? If a measure of angle A equals 29 degrees and measure of angle B equals 29, then measure of A equals measure of B. I'm accepting 2 answers for this. No, because I'm not converting from congruence to equality. No. One way here, if measure of angle A was 29, I could have substituted like that. So substitution is one way. Another way, I could have said if measure of A is equal to 29 and 29 is equal to the measure of B, then measure of A equals measure of B by the transitive property. And the transitive property, all transitive properties are a type of substitution, but not all substitutions are transitive. I'm going to leave that mysterious for now. I'll let you guys ponder that one and your lives for a while. Actually, it'll probably be resolved right here in 46. So let's see. In the diagram, AC is equal to BD. So that's El Grande length. Right? Those are congruent. Show that AB is equal to CD. So let's see how quickly I can do this. So AC equals BD. That's given. Gimme. Right? And I'm gonna make like what we'll see today are called 2-column proofs, where I put my statements on one side and my reasons on the other. Statement and reason. So let's see. You guys all know this. Well, actually, I don't even need it. Do I? No, do I? Do I need to switch to congruence? No, I'm just going to go with segment addition postulate right away. I'm going to say AC is equal to AB plus BC. Yeah? And I think I can make a similar claim about BD. Yes, sir. You might have pre-rearranged it, I'm guessing. So you said BD plus what? Oh. Yeah. You probably definitely could do that. Yeah, so you were doing like seg-add post for like the entire thing. Right. That's what I thought you were going to say. So I'm hearing like someone did a segment subtraction postulate, which doesn't technically exist. What that ends up being is it's segment addition postulate plus subtraction property of equality, which is, so I'm going to more formally walk it out. But yeah, your logic is identical. So let's see. So BD is going to equal, I'll call it CD plus BC. Now, so these are all true by seg add post. Right? Ditto. I think I could use some transitive here. Yeah. Oh, yeah. Yeah, transitive. You could use substitution as well. Yeah, I'll do it substitution way if you'd like. So since, well, that actually that's gonna. Let me do triple transitive, double transitive. Here we go. Watch this. AC is equal to BD. BD is equal to CD plus BC. All right, so I could end up saying that these two things are going to be equal, right? However, even more so, I know that AC is equal to AB plus BC. So let's see if we can follow this transitive train. So this is equal to that, which is equal to that, which is equal to that, which is equal to that. And therefore, the engine is equal to the caboose of the transitive train, friends. No? I just got like a sigh, like a really good sigh from one of my students. You can hear that sigh and more at Liam Math, where he sighs about mathematics. Or lame jokes, maybe. I don't know which it was. Yeah, the best of size 2017. So this is true by transitive property. There's ways you could accomplish similar things using substitution, though, like so. And that's my transitive train that I showed there. And then watch this. What if I just write AB equals CD? Why is that true? Well, that's what I'm trying to prove. But the way I got there was this unwritten step for proofs. Subtraction property of equality. All right, so thanks for watching, internet friend.